So thank you for being here. I would like to, or I try to tell you something about this theme embodied energies. And I say I try, you will see why. So we start here. There's text missing on the upper side, but don't mind. It's a bit in the sense of once upon a time, people had to protect against the cold, the coldness, the wet, the rain, the flood, stormy weather, and so on, and the wild beasts. And so they had to find some shelter to protect. But it was cold in these caverns, so they had to invent the fire to get some heating and fire for other supplies, for other opportunities. What then happened? It was so comfortable in these hot caverns that the population grew. And we had so much population in this world that the caverns were not anymore sufficient for these people. What should we do now? That's what had been done. That's the view of Sao Paulo, a big city. So we have a lot of houses, a lot of settlements, several million of people living here. There's no more nature, no more space. And we are polluting, we are abusing our environment. Trying to understand what could be done. Oh, it's really bad. Okay, this is one global context. There is 3 points. The global context we have to consider: climatic, geopolitical, economic, cultural, social issues. The thematic fields, I only mention soil, air, water, energy. You will see why. And afterward, there are the action levels. It's the levels where we are working on. The first one, the global context. There should appear some words now if I click demography, political situation, primary energy use per capita and year, deforestation, degraded soil. I go on a bit quicker. And this is the global context we have to consider when we are speaking also of energy and resources. Okay. Then we have these thematic fields. And this is the air, the water, and the soil. So all these 3 are components, compounds that we are using as resource, and we are emitting in the air, in water, in soil by our acting. And in all this, there's energy, which plays a crucial role, or an important role, should I say. And there has to be a balance between all these 4 elements: air, water, soil, energy. Yes. And it's a bit our duty to protect these resources and to decrease or avoid emissions. And in fact, in a certain kind of definition, these 2 points, protecting resources and decreasing or avoiding emissions, are the basic points of sustainability. So the action levels, for example, the environment globally thought, and perhaps cultivated landscapes, there's a wilderness, and we will follow the left path. For example, the next level, towns, villages, built areas. Other will work on forest areas, agricultural areas, hydrological areas, and so on. Then we go beyond on buildings, the other hand, they are open space, not built areas. We're going down to the type of buildings, production, living, commercial, and so on. In the open spaces, we have, for example, playgrounds, parking, and other places, and so on. So you go beyond, and on every level, you have the discussions about resources and emissions. And we go down to the walls, for example, perhaps wooden walls, why not? So we have these 3 points, the global context, the fields, and the action levels, who has to be combined and viewed together. Efficiency. So, this is a well-known figure. I think all of you will know it. It's about, c'est un cercle, it's a circle, it's the circle of sustainability. And perhaps we start from raw material extraction, are going to production of building materials, elements. We are building a house, it's construction, the use stage, the deconstruction. And if all is going well, we can pass directly from the deconstruction to the production of building elements and restart from zero. Otherwise, we will have the stage of waste disposal or disposal of the unusable material. So, and mostly we are occupied by viewing and dealing and calculating in the field of the use stage. So our energy efficiency debate is mostly about these figures. The EPCs are based on that. So, and here I show you some figure. It has been calculated from the university in Darmstadt. The development of the EPCs of the different standards coming from, this is not very important, but 84 to 2007 in Germany. And you see red amount of heating, hot water, additional current for heating, electricity, and construction. And the further we are going on, the more this gray color is getting important. All of this is getting smaller, but at the end, the last one, the construction, is getting very important. So it's a almost zero energy house, and we have it here, and at the end it's 100%, and this should be our challenge, the new challenge in thinking energy. So now we try to analyze and to quantify. This is a difficult field. I brought this slide, Projektplattform Energie, Leitfaden ökologische Kenndaten. Oh, there's always something missing. It's from Bavaria in 2014, and it's a kind of guideline for ecological data for building materials and building components. And you have something about the sustainability and resources, the characteristic of these materials, and then in a kind of database. And here, for example, I think I put it in red. You see one chart. You have the pi values. Pi in German is Primärenergieinhalt. It's the contents of primary energy, or the gray energy, Energie grise. En fait, you see here in the red some values you can work with if you do know how to work with these figures. In this leaflet, you have also a kind of overview in a very simple way. I think it's very good for architects who are not going very deep in this matter. And with a very easy kind of plus and minus, there's a description of building materials. And you have, for example, primary energy content, Transportweg. It's the distance of transport and the CO2 emission values. And you have, for example, the bricks, the béton cellulaire, it's a kind of light concrete, and other materials. Okay, and so it's for your first overview. Yeah, I will go on quickly. It's another one you will know, the RICS, Royal Institution of Chartered Surveyors. You see the typical projects, the embodied carbon on the left side is operational carbon, the regulated energy, that what I showed you before in the red circle. And these are the typical or normal project, the low carbon project and the zero carbon project, and you have the same figure. There's only left energy in the embodied sector. So perhaps you will know this. It's repeating in different figures, and we are coming here to the building assessment information with the different building life cycle information. And perhaps you know we have these states from A till D, from the product stage to the construction stage, the use stage, end of life, and afterwards. In D, we have some additional qualities. And I go on further. It's a DIN. I calculated an example from a small house of 16 units. We took the square meters and the percentage of the building and took the building elements. I think it's a PDF, it's not a PowerPoint presentation. Okay. And I used the Ökobaudat in Germany. It's a very big database for the data we use for these calculations. And you see, for example, you have the mineral elements, you have insulation materials and all this. And this is an example. You have the phases of A, here C and D, and you have the values you can calculate with. I did it with this building, and you can see a little bit the material proportions, the values in cubic meters. A lot of concrete and a big amount in cubic meters of insulation. This is not bad. This is, yes, I hurry up. What's interesting is to see the primary energies in these materials, the renewable and non-renewable amount. Non-renewable is the red one. For example, the insulation, you have a very big amount of non-renewable energies. So, and you can go further on and make different combinations to see, for example, the glowing warmer potential, and the last point, the wood, as a negative one. So you yeah. It's the same here. Okay. Okay, so this was a very rough one. I entered a bit more deeply and established, in this case, 20 different outwall constellations. I will not explain all of them, but you arrive to, with selected indicators, to see a little bit what's going on and what perhaps can be chosen afterwards. What is very difficult at the end to see in our values, in our database, that there's a lot of values, they don't exist. So, for example, we have the values of the production of the material, and there's no data for the rest of life. And in some cases, it's 50% of energy which is going on in these values. So in all these buildings, there's a lot of energy, and we have to learn how to measure it. And even in electrical plants and photovoltaic installations, in this kind of nice decoration of buildings, the ACs, it's a solution for the indoor climate. It's a small solution, but you make a very big input of energy by building them and putting them in these situation in these apartments. Amendments, it's the same. It's our ACA amendments. I think this morning we talked about. I wouldn't like to repeat the last pictures. A lot of embodied energies staying here, recycling embodied energies, recycling every time possible. Afterwards, new wooden constructions here in London, you will know it, I think. In Germany, we have the kind of competition about wooden buildings in commercial buildings and official buildings. So it's very important. We have a lot to do. I think this is true. We are responsible for every of our acts, but also for not acting at all. So we have to go on. And renewable energies, resources, design, functionality, affordability, climate friendliness, sufficientness, and at the end, renewable children, grandchildren. For them, thank you.